Question number 4 on exercise 2.2b reads that using diagrams, that is circle, we should find the HCF of 75 and 90. The HCF means the highest common factors of 75 and 90. And in order for us to do this using circle, we shall use prime factorization to determine the factors to express 75 and 90 as the product of its prime factors. Thereafter, we then select the factors that are common to both 75 and 90 and represent them on a diagram. We shall be using circle where we will have an intersection, and that intersection gives us the region where we have the prime factors that are common to both 75 and 90, and the product of these prime factors gives us the HCF of 75 and 90. We shall express 75 and 90 as a product of their prime factors. So 75 is not divisible by 2 because the last digit of 75 is not a multiple of 2. So we shall test for 3. Is 75 divisible by 3? Yes, because when you add 7 plus 5, it gives you 12. And 12 is a multiple of 3, which is the condition for a number to be divisible by 3. So 3 into 7 is 2 times remainder 1. 3 into 15 is 5. Is 25 divisible by 3? No. Reason being that 7 is not divisible by 3, which is a sum of 2 and 5. So we test using the next higher prime number, which is 5. 5 into 25 is 5 times, and 5 into itself is 1. So therefore, we have it that 75 can be expressed as a product of its prime factors as 3 times 5 times 5. We do same with 90. 90 is divisible by 2 because the last digit is divisible by 2. 2 into 9 is 4 times remainder 1. This becomes 10. 2 into 10 is 5. 45 is not divisible by 2 because 5 is not a multiple of 2. So we test for 3. Is 45 divisible by 3? Yes. Because the rules for divisibility by 3 is that the sum of the digits of those numbers must be a number that is a multiple of 3, or a number that is divisible by 3. And 4 plus 5 is 9, of which 9 is a multiple of 3. So 3 can divide. 3 into 4 is 1 times remainder 1. This becomes 15. 3 into 15 is 5. 3 can still divide 15 because 1 plus 5 is 6, and 6 is a multiple of 3. So 3 into 15 is 5. 3 can no longer divide 5, and then we use 5. 5 into itself is 1. So that expressing 90 as a product of its prime factors is said to be 2 times 3 times 3 times 5. Then we look at the common factors. 5 is common, and 3. So representing this using diagrams, we now have this and this. This will be the region for 75 and 90. In the intersection where they are overlapping, we have 3 and 5. Then those factors that can be found only on 75, say just 5, and on 90 it is said to be 2 and 3. So this is how you represent it using diagrams. Now, how do we determine the HCF? The HCF of 75 and 90, we say, is the product of all the digits you find in the intersection. So this is going to be 3 times 5, and 3 times 5 is equal to 15. So 15 is said to be the highest common factor of 75 and 90. Remember, you can also use other methods in looking for the HCF, but based on the question that demands we use the diagram, this is how to do it. Kindly like my videos as you watch. While I recommend that you subscribe to my channel on YouTube and on Facebook, also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. Well, I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take the next question on exercise 2.2.